We're actually talking to a program who talks to another program who tells the computer what to do. We as human beings cannot understand in the same way that a computer can the ons and the offs, the bits, the bytes. So we have to turn it to a language. In a few weeks, we're going to talk about this language of doing it. But in order for us to understand, we live in a world of metaphors. We talked a little bit about this. When we go to the computer now, it's the metaphor of the office, right? Here's a file, here's a folder, we throw something in the trash. It's all a metaphor of the office, right? We live in a world of metaphors. Even we're talking about the web, we surf the web. Even the idea of web pages is a metaphor that we have created so we can interact electronically. Last time we were here, we talked about images. We were talking about images. And I will tell you that I told you that the camera is real. The camera is real. And in the old days, the camera was a mechanical thing. A piece of wood, a piece of metal, a piece of glass. And it was a real thing. But now, if I go and buy a little camera, a little digital camera, this is a metaphor. The camera itself is a metaphor. I could take the camera and break it open. It would fall in pieces. And I could pick up this tiny processor, and this is the camera. But we as human beings can't do that. So they have to make it look like an old camera. We look through a viewfinder, we press a thing, our big old fingers can get around it. But that's not really what it is. That metaphor is there for us to understand what's going on with the camera. If I play a guitar, guitar is made of wood, with strings, with little pieces of ivory or whatever they're using now, and the strings are turned, and when I strum the strings, the waves go through the air and hit you because of a physical instrument, right? But we don't do that anymore. This is not a piano. This is not a piano. This is a lie. This is a fake. This is a metaphor. This is a piece of plastic. I can break this open. There's nothing inside when I hit it that hits something else that reverberates and makes us listen. I can get a guitar now. And you guys, everybody was into it for a while. What was it? Garage Band and Rock Hero. Yeah, all those things that we used to do, we don't do anymore, right? Barracuda. Everybody knows Barracuda, though, right? But that guitar was a plastic guitar, too, right? We put things on there. That was not a real guitar. That was a metaphor for a guitar. This is a metaphor for a piano. This is a piece of plastic, has nothing inside it that really makes music. Nothing at all. We're going to talk a little bit about that today, Sam. And we're going to write a song with this metaphor, too. I can actually get a piece of plastic, shape it in the form of a saxophone, and I can put some electronic things inside it, and it'll look like a saxophone, and I can get down with it, but it is not a saxophone. A saxophone is a piece of brass that has certain holes in it. When I blow through a reed, makes sound come out. But in the digital world, that's not how sound works. In your world, that's not how sound works. And the difference, when I play that guitar, we're talking about analog sound, right? A continuous stream of music. When I play the metaphor, it's digital sound. So let's talk a little bit about that. This is the last thing some of the last things I want you to know for our test. But let's talk a little bit about sound, how we deal with it, how it affects our lives, how we can create sound and be consumers of sound. So, in this class, the sound is created by the movement of air molecules through a medium. Sound is created by the movement of air molecules through a medium. And we measure the change in sound, in real sound, through pressure. Our eardrums, there's the three bones in our ears that move. You're hearing me talk now because it's coming out to you, it's hitting your eardrum, it's hitting it a certain way. We measure sound through changes of pressure. There are two things I want you to know about sound. Well, there's more, but here's the first two things. The first is called amplitude, and the second is called frequency. When we talk about the amplitude of sound, we're talking about the volume, the loudness, the intensity, the sound pressure. This is amplitude. As a matter of fact, when rock stars go on stage, they plug into an amplifier, and they turn it up to 11 if you watch certain movies, right? Amplitude. Amplitude is the volume and the loudness of sound. Frequency is the other side of sound, the other part of sound, and this is the pitch or the tone of sound. We measure amplitude in decibels. You you live next to an airport, they tell you the decibel of sound of a 747 coming over your house. The loudness is measured in decibels. Frequency, which is the pitch and the tone, is measured in hertz. Now we can view this on a graph. We can view this on a graph, and I'm going to start by showing you this because this is called a sine wave, S-I-N-E, sine wave. Don't worry about all the other things. Just look at the red thing going up and down. You guys have seen this. And I'll tell you, if you're going to make gains, the sine wave is a magical thing. The sine wave controls where the gun goes, how far it shoots, how it moves around. This is a magical thing to game making. The sine wave can be used in a lot of ways. For us, however, it can be a graph that shows the frequency and the amplitude of sound. We can see amplitude on a time graph, and we measure hertz by the number of cycles per second.